Hi, this is Calandra. In this video, we'll talk about different properties of functions. First, we're looking at what it means for a function to be increasing or decreasing. A function is increasing if its graph rises when moving from left to right. A function is decreasing if its graph falls when moving from left to right. A function is said to be constant if its graph is horizontal. So in this example, specify the increasing and decreasing intervals of the following functions. And let's also put in constant. Increasing, decreasing, and constant. Okay, well, for our first function in gold, we see that it's never constant because it's never horizontal. But we do have some increasing intervals. So I see that it's rising for this portion of the graph, so it's going to be increasing here. It's falling for this portion of the graph, so that will be decreasing. And then we see that it's rising again for this portion of the graph, so it's increasing. So we need to specify this in interval notation, and you want to make sure that you're using your x values when describing these intervals. So that'll tell us, when looking at your x, what portion of the graph we're referring to. So our function is increasing if we have any x value from negative infinity until we get to this point here, -5. And we're not going to include that point, so we're just going to use a parenthesis. And then the function starts increasing again when we get to an x value of 2. Again, we're going to leave that point out because we don't talk about a function increasing at a point. It's always in an interval. So it's going to increase as soon as I get to an x value of 2 and anything larger, which means okay, our function is decreasing in one interval, and that's between -5 and +2. Again, make sure you're looking at your x values only when giving these intervals. Okay, going on to our next function. First, we want to see where the function is increasing. So we see that it's rising in this first interval, and it's rising in 2 additional intervals. And notice that we have to break these two up because there's a gap in the curve because of the open circle. So we have to make sure to leave that point out because a function cannot be increasing where it's not defined. Okay, so this function is increasing using our x's from negative infinity until I get to an x value of -5. That point out, since we don't talk about increasing at a certain point, so we'll have our -5 with a parenthesis, union, and it's increasing again when I get to an x value of 2 until I get to an x value of 2, 3, 4, of 6. We leave that out because we have an open circle, so the graph doesn't exist there. And as soon as I go to the right of 6, it continues to increase, so 6 to infinity. Okay, is this function decreasing anywhere? No, it's never falling. Remember, you're always looking from left to right. So even this, though the arrow is pointed down, moving from left to right, we see our function's actually increasing. So it's never decreasing, so we can just put the empty set for that. And we do have a portion of this graph that's constant, meaning it has the same y value, so it's horizontal between -5 and 2. So again, we'll use parentheses since we don't talk about increasing or decreasing at a single value. Okay, going on to our last graph. Okay, increasing, meaning going from left to right, the graph is going up, So I see it's increasing on the right side, and it's actually decreasing in this portion. So my intervals for where it's increasing, we want to make sure we're using our x values. So that will be from 0, an x value of 0, to positive infinity. It never stops increasing. My function is decreasing for any negative value of x until I get to an x value of 0. So from negative infinity to 0.